Okay, today we're going to be doing additional lesson 2, which is going to be solving inequalities with absolute values. So when I'm talking about inequalities, I'm saying that we are going to be having something like an absolute value of x plus 2 is less than 3 or less than or equal to. You could also, instead of a less than sign, could end up with a greater than or greater than or equal to sign. Okay, so before we get started talking about that, I want you guys to go through this bell ringer. Bell ring just has a couple questions like we went over last time, so I want you guys to pause the video and solve these two for me. Okay, hopefully you guys have paused the video and solved these two on your own. Okay, first one over here. Remember when we have the absolute value of that 3x minus 1, there are two numbers that I could be plugging into that absolute value to make that true. I could have a negative 10 inside of that, or I could have a positive 10 inside of it. So we're going to set the inside, 3x minus 1 is going to equal a negative 10 or a positive 10. We're going to set them both equal to that. So 3x minus 1 could equal 10 and make that true, or 3x minus 1 could equal a negative 10 and make that true. Add 1, 3x equals 11. Divide by 3, I get x equals 11 thirds. Okay, again, add 1, 3x equals negative 9. Divide by 3, x equals negative 3. Okay, so pretty simple there, remembering that we're setting up our two equations. Then the next one I have absolute value of 2x plus 5 minus 4 equals 7. Okay, this is one, hey, can I say that 2x plus 5 has to equal 7? No, not yet, because we need to remember that the first thing we have to do, number one, is we have to isolate the absolute value. And when I say isolate, I mean we have to get it by itself. Okay? So the first thing I need to do with this problem is I would need to add 4 to both sides, which gives me the absolute value of 2x plus 5 equals 11. Sorry, not 7. Equals 11. Now, I can do the same thing. That 2x plus 5, well, what could go in there? There could be an 11 in there, and that would make that true. Or there could be a negative 11, and that would still make that statement true. So we're going to take that 2x plus 5, and I'm going to set 2x plus 5 equal to a positive 11, and I'm going to set 2x plus 5 equal to a negative 11. Okay, subtract my 5, I get 2x equals 6. Gives me x equals 3. Subtract 5, I get 2x equals negative 16. Divide by 2, I get x equals negative 8. Okay, so hopefully that jogs your guys' memory on what we are doing for your guys' bell ringer. So now what we are going to do is we're going to move on and we're going to look at a couple cases if they have an absolute value sign. Or sorry, if they have an inequality with that absolute value sign. So first case we're going to look at is we're going to look at what if we have an absolute value of x less than 4. Okay? And what I want you guys to do is I want you guys to pause the video and brainstorm. What are the possible values of x that we could plug in there that would make that statement true? So pause the video, give me all the x's you can think of that would make that statement true. Okay, so hopefully you guys paused that video and found some for me. So let's just kind of run through and see what we can come up with here for values that would make this statement true. Well, absolute value of something needs to be less than 4. Sorry, absolute value of something needs to be less than 4. Okay, so a lot of you guys could probably think of some as you're running through here. 3. Would 3 be less than 4? Absolute value 3, yeah, that's just 3. 3 is less than 4. Okay, so 3 is one of our possibilities. What about if I did 2? Absolute value of 2 less than 4? Yeah, it is. So 2 would also be a potential answer. 1, yes, absolute value of 1. Okay, you kind of get the picture here, 0, okay. Absolute value of negative 1, well, the absolute value of negative 1 is just 1. Is 1 less than 4? Yeah, that's true. Okay, so when we do those negatives, though, all of a sudden something starts to happen, right? Absolute value of negative 2, well, that gives me 2 less than 4. So now I'm kind of starting to get closer to that 4, and I'm going to eventually hit negative 3, right? Well, what if I did an absolute value of negative 5? So negative 5 is less than 4, but we're not talking about negative 5. We're talking about the absolute value of negative 5. The absolute value of negative 5 is 5, which is less than 4, and that is not true. Okay? So when I'm looking at this case, or answers for this that are true, 0 would be true. 1, 2, 3. 4 would not be true in this case because it's just less than. It's not including the equal to. But 0, 1, 2, 3 would be true. Okay? Also, -1, -2, -3 would also be true on this. Okay? But any of those other bigger numbers that I put, if I put absolute value of 7, obviously that's not true. Okay? If I change that and make that an absolute value of -8, that's also not true. Okay? Basically, I can pick any number in here, okay, but not including 4 and not including a -4, right? But all of the numbers in between -4 and 4 would be true answers. Okay? I'm not including -4, I'm not including 4, but all of the numbers between those two. Okay? Now, this is all the way back to Unit 1, but hopefully you guys look at that and recognize that is a bounded interval. Okay? So when I have a less than sign, and you'll find that that's also a less than or equal to sign, we end up with a bounded interval. Okay? And bounded intervals look like, hold on, let me erase this real quick. My bounded intervals are the ones that look like when I have the x in the middle of them. So the absolute value of x less than 4 ends up giving me -4 is less than x, which is less than 4. Okay, and that's the ones where I would say if the x is in the middle, then we shade in the middle. If the x is in the middle, then we shade in the middle. Okay? So the absolute value of x less than 4 equals a -4 less than x less than 4. Okay? So just like before, when I was solving equations with absolute values, we set up two equations. Okay? So what's going to happen with an interval, when I set up an interval, I'm going to end up with a compound inequality. And compound inequalities are basically two inequalities. Okay? Our less than signs, however, are going to end up giving us bounded intervals. So our blanket statement that we can make is, if I have the absolute value of x is less than a, what's going to happen is I'm going to set up not two equations, but I'm going to set up a bounded interval, and it will be -a less than x, which is less than a. So if we isolate our absolute value and it's a less than sign, instead of setting up two equations, we set up a bounded interval. Okay, so let's practice. I've got an equation up here. I've got absolute value of 2x plus 4 is less than or equal to 3. First thing we have to do is just like solving equations. I have to make sure that I get the absolute value by itself first. Okay, the absolute value is by itself, so we're good there. We need to remember the absolute value of x less than a gives us a -a less than x less than a. Okay, so I've got my absolute value by itself. Now, x gives me an x in the middle. But on the inside, I no longer have the x. What do I have on the inside? Well, I have a 2x plus 4 on the inside. So in the middle, I'm going to now have a 2x plus 4. And then I have two less thans on each side of it because I'm setting up my bounded interval. And since I have a less than or equal to 3, these both need to be less than or equal to as well. Okay? Now my a, which was this side over here, I need to have a positive a on the right side and a negative a on the left side. So what is my a in this case? Well, my a is a 3. So I'm going to have a 3 on the right side, and then I need to have a negative a, so I'm going to have a -3 on the left side. Okay? Now, some of you guys, once we get to this point here, we're just going to solve it. Some of you guys might not remember. If you're solving a bounded interval, basically what you're trying to do is get your x by itself just like before. But if I do something in the middle to get rid of something, like I'm doing there, I have to do that on both sides of the inequality as well. So I end up with a -7 less than or equal to 2x less than or equal to -1. Okay? I'm still trying to get 2 by itself, so I'm not quite done yet. I'm going to need to divide by 2. It means I have to divide everything else by 2. And that gives me a negative 7/2 less than or equal to x less than or equal to negative 1/2. And that's my answer. Okay. Now you are going to be asked to graph these. Okay. You are going to be asked to graph these. So we need to remember, okay, and this is how I explained it to you guys in Unit 1. If the x is in the middle, then we shade in the middle. So my x is between a negative 7/2 and a negative 1/2. So I'm going to put negative 7/2. I'm going to put negative 1/2. Okay. They both need to be closed circles. They're both going to be closed circles because we've got or equal to there. And then since the x is in the middle, I shade in the middle. Okay. So this is what my graph should look like on this case. Now, the next thing I want us to do, that's what we're dealing with on less thans. We're going to skip a few pages in our notes, and I want you guys to go to this practice page. Okay. So go to this practice page here. And I've got an absolute value of x minus 9 is less than or equal to 3. Pause the video, okay? Or if you need to, rewind it and watch the last one we just did, but I want you guys to solve this practice one here. Okay, hopefully you've solved the video, you've tried it on our own. Okay, so I've got my absolute value by itself first. That's by itself first. So I've got a less than or equal to. Less than signs mean absolute value of x less than a. Okay, that means that I need a negative a less than x less than a. Okay, so my x in this case is an x minus 9. Okay, that's in the middle of it. I've got my two less than signs on each side, and they need to be less than or equal to because our problem is dealing with a less than or equal to. Okay, then my a value in this case, my a value is a 3, so I've got a positive 3 here and a negative 3 on this side. Whatever I do in the middle to get the x by itself, I have to do on both sides. So I end up with a 6 less than or equal to x less than or equal to 12. Okay, go ahead and graph that there as well. If the x is in the middle, we should be shading in the middle. So I've got, whoops, not 12. Smaller number would be on the left. I've got a 6. I've got a 12. Again, it's less than or equal to, so they'd be closed circles. And since the x is in the middle, I shade in the middle. Since the x is in the middle, I shade in the middle. Okay? All right. Next video, we are going to look at what to do if there's a greater than sign. And then we are also going to talk about a couple of special cases that can occur.